Does enthalpy depend on pressure and volume? Have you ever wondered how the concepts of pressure and volume influence something as fundamental as enthalpy? Let's break it down in a straightforward way. Enthalpy is defined as the sum of a system's internal energy plus the product of its pressure and volume. This means that pressure and volume are directly included in the value of enthalpy. When we say enthalpy, we are referring to a specific state of a system, which is determined by its temperature, pressure, and composition. Now, let's talk about how pressure and volume affect enthalpy. Since enthalpy includes the pressure and volume term, any change in either of these factors will lead to a change in enthalpy, assuming the internal energy remains constant. This relationship is particularly noticeable in gases, where changes in pressure and volume can significantly influence the overall enthalpy. For ideal gases, the situation is a bit different. In these cases, enthalpy primarily depends on temperature rather than pressure and volume. This is because the internal energy of an ideal gas is a function of temperature alone. The relationship between pressure, volume, and temperature can be described by the ideal gas law, which states that pressure multiplied by volume equals the number of moles multiplied by the ideal gas constant multiplied by temperature. However, when we look at real substances, the story changes. For real gases and liquids, enthalpy can vary with changes in pressure and volume. This means that if you were to adjust the pressure or volume of a real substance, you would likely see a change in its enthalpy value. Another interesting aspect of enthalpy is its role in thermodynamic processes. When a process occurs at constant pressure, the change in enthalpy is equal to the heat exchanged by the system. This makes enthalpy a practical quantity in fields like chemistry and engineering, where understanding heat transfer is essential. In summary, enthalpy does depend on pressure and volume due to its definition. While the exact relationship can vary based on whether we are dealing with ideal or real substances, it is clear that changes in pressure or volume will lead to changes in enthalpy. Understanding this relationship is key to grasping the principles of thermodynamics and how energy transfer works in various systems.